So this is a video that I'm creating because I have had the most questions about these two concepts: finding the fourth point in a parallelogram, which includes a rectangle, a rhombus, or a square, and then how to determine if a parallelogram is a rectangle, a rhombus, or a square. So we're going to go over both of those concepts today in this video. First of all, it says I'm going to show you the first way I'm going to show you how to find this fourth point is by using a graph. So given that MNPQ is a rectangle with the vertices of M3, 4, and 1, -6, and P6, -7, find the coordinates Q that make this a rectangle. So I'm going to plot the M and the N and the P. Now what I'm going to do is I'm going to use the slope. Remember, we know rise over run, right? So we're going to use that to find our point Q. So we know this is a rectangle is a parallelogram. So we know that side NP down here, this side has to be parallel with a point from up here to the right that would be Q, right? So what I'm going to do is I'm going to count one down right here. Let me show you this again. So we're going to count one down and then 1, 2, 3, 4, 5 to the right. Wait, did I count that right? 1, 2, 3, 4, 5 to the right. Yes. So one down and 5 to the right. So now what I want to do is I want to go one down and 5 to the right. 1, 2, 3, 4, 5 to find my point Q. And when I do that, I'm going to find out that it is at 8 to the right, and 1, 2, 3 up, 8, 3. So that's one way, by using a graph, which obviously means you guys got to have graph paper, which there will be a link on the test for you guys to have graph paper. So then another way is that we could use this fact that the slopes of opposite sides are equal. So we could use the slope formula. So here I'm going to go ahead and plot our 4 points because this just helps me visually see what I'm talking about. So we're going to be talking about the slope of NP in relation to the slope of MQ. Well, we don't know where Q is, right? So that's what we're going to be looking for, our Q point, right? So it's going to be question mark, comma, question mark, when we're working it this way. Okay, so when we do this, that's our slope formula, y2 minus y1 over x2 minus x1. So I'm going to find the slope of NP down here by plugging in these values, -7 minus a minus 6, and 6 minus 1. So when I do that, that's going to be -7 plus 6. That's going to be -1, and it's going to be 6 minus 1, which is going to be 5. So this is the slope of NP here, which we kind of already knew that because we did it on the prior problem. The way that we did that one, it was 1 down and 5 over. So what we're going to do now is we're going to find the slope of MQ. We're going to use the slope of MQ, which should be the same as the slope of NP. So we're going to set those equal to each other. So now what we don't know up here is we don't know what our y2 and our x2 are here. So that's what we're actually going to be solving for. So we're going to set this up, y2 minus 4, and then x2 minus 3. Then we're going to set that equal to our -1 over 5 because the slope should be the same. So we're going to do this top part right here. So we're going to do y2 minus 4 equals -1. That means we're going to add 4 to both sides. And the bottom part here is x2 minus 3 equals 5. So again, we will be adding 3 to both sides here. Notice when we do that, we get the same point that we got the previous way. Now there's one more way that we could do this. We could use the midpoints. Now remember that with any parallelogram that the diagonals bisect each other, so they should have the same midpoints. So here's the third way. Again, we're going to go ahead and sketch it because again, I'm a visual person. So with this one, we're going to be talking about the midpoint of MP. So we're looking at going from here to here, right? And we're looking at this midpoint in here. Well, obviously the midpoint of MP is going to be the same as the midpoint of MQ, right? And again, we don't know what our Q is, so this would be our X2, Y2, right? Okay, so when we're trying to find our midpoint, we add the 2 points together. So we're going to add the 3 to the 6 and divide by 2, and we're going to add the 4 to the -7 and divide by 2. When we do that, we get 9 over 2, and we get -3 over 2. Now what we're going to do is we're going to simplify those. That's going to be 4.5 and -1.5. Now once again, we're going to use this midpoint formula to find what the values are up here. Now this time we have our midpoint. It's 4.5, -1.5. So we're going to do this the way I taught my students, which was We're putting the midpoint over here, and then we're going to solve for the other value of x over here. So when we do that, we're going to multiply both sides by 2. That's going to give us our 9, and then obviously we're going to subtract the 1 from both sides. That's going to give us the 8. Now the other one was negative 1.5. That was our midpoint. And that's going to be equal to negative 6 plus our y. And we could say y2 here and x2 over here. Again, what are we going to do to get rid of that 2 that's in the denominator? We're going to multiply both sides times the 2. That's going to give us negative 3 equals negative 6 plus y. And then we're going to add 6 to both sides. So here again, this was the third way that we could have found what the other endpoint was in this parallelogram. And again, it doesn't matter what kind of parallelogram it is, guys. It could be a rectangle, a rhombus, or a square. The process is the same for all three. Now, here's the other thing I keep getting lots of questions about. So what type of parallelogram is this quadrilateral? So given the vertices of J, K, L, M are J, K, L, and M, determine if it's only a parallelogram or if it's a rectangle, rhombus, or a square. So let's go ahead and plot these points. I kind of like to do that. At least it gives me a visual input. Now, when I'm looking at this, it looks like it could be a rectangle, it could be a rhombus, or it could be a square. So let's go ahead and see what the process is we need to work through to determine exactly what it is. So the first thing we're going to do is calculate the distance of all four sides. So that's why I kind of like to plot these, because then when I work through these, I can see that JK is a side, KL is a side, LM is a side, and MJ is a side. Now what I'm going to do first is I'm going to do the opposite side. So I'm going to do JK. I'm going to use my distance formula here to find the distance, the length basically of JK. So when I do that, remember once again, when I got a minus, it's going to be plus here. So that's going to be 3 plus 1, which is 4. This is going to be 3 minus 0, so that's 3. Take the square of both. Remember your PEMDAS process. Do your parentheses first, then your exponents, then you're going to add. So that's what we did here. So 16 plus 9 is 25, and the square root of 25 is 5. So that's our JK. It's 5. Now let's compare the opposite side over here. So now we're going to find LM. So LM is, again, we're doing these points up here, if y'all notice, these points up here. So this is 2 minus 6, negative 4, minus a minus 1. Again, remember this is going to end up being plus. This is going to be 4 in our first set of, no, sorry, negative 4 in our first set of parentheses. And this is also going to be a negative 3. Remember, anytime we square any number, it always becomes positive. So here again, we get 16 and 9, and that's going to be 25. The square root of 25 is 5. So we do know already that this pair of opposite sides, JK and LM, are congruent. Now let's look at our next two pairs of sides. We're going to look at KL, and we're going to look at JM. So here again, we're going to populate our formula for our distance formula. We're going to do what's in the parentheses first. Then we're going to keep simplifying as we move down. This again is 25. Well, wow, I'm seeing a pattern here. So this KL is also 5. Now let's see what MJ is. So when we do MJ, here again, remember our minus and minus, that's going to be a plus. Keep working through this problem. So this one again is 5. So all four sides are congruent. So that means that this shape is a rhombus. At the very least, it's a rhombus. So because all four sides are congruent, we can say that JKLM is a rhombus. But is it only a rhombus? Because remember, if four sides are congruent, it could also be a square. So what we want to do next is calculate the distances of the diagonals. Now, if the diagonals are congruent or equal, then we can say that this is a rectangle. So let's compare the lengths of our diagonals. So let's find the length of JL. So notice here is our JL, and it's a diagonal, JL right there. So when we do this one, we, again, minus and minus, that's going to be 7 there, and this is going to be negative 1. Anytime we square any number, it becomes positive. So the JL is going to be the square root of 50. Then let's look at the other one, KM. So when we do KM, let me go ahead and move this out of our way here. Once again, we get the square root of 50. So our diagonals are also congruent. What does that tell us? That tells us that this is a rectangle. So because the diagonals are congruent, we can say that JKLM is a rectangle. Well, if something is a rectangle for congruent sides, and a rhombus for congruent sides, and it's also a rectangle. So let's do this. Let's go ahead and draw this now, and let's label it with what we know. So what we know is that all four sides are congruent, right? And we also know that all four angles are congruent. They're all right angles, right? So because we know this, we can say that this, because JKLM, let me see if I can move this over here, because JKLM is a rhombus and a rectangle, JKLM is a square. So you guys want to use these properties when you guys are doing these types of problems. To determine if it's a rectangle, if it's a rhombus, and if it's a rectangle and a rhombus, it's a square. That's why I did this one, because you need all of it. So remember, if all you see is that four sides are congruent, then it's a rhombus. If all you see is that the opposite sides are congruent, then it's a parallelogram. If all you see is the opposite sides are congruent and the diagonals are congruent, then you can say that it is a rectangle. Okay?